And we're live. Welcome. This is Benjamin from Eclipse IoT and from Virtual IoT. We are back for another Virtual IoT session. Today we've invited Marcus, who's been involved with the Eclipse IoT community for a long time now. And Marcus is going to talk today about some modeling techniques for IoT. We always talk about the foundation, the technology for building IoT solutions, like the protocols that you need, the frameworks, etc. But we sometimes forget that it's also important to have good tool chains, good tools for developing and maintaining IoT solutions on the long run. So welcome, Marcus. Good afternoon. Yeah, I'm really looking forward to learn more about what you've been doing. I think you've extended the good old Eclipse IoT greenhouse demo. So without further ado, I would like to welcome you again, and I will leave it to you to do the presentation. There's maybe a quick reminder before we start. Questions would be directed to Marcus by means of commenting on YouTube. That's probably the easiest way, actually. You can directly engage on the YouTube channel and comment directly on the video, or you can also ask questions and interact on Twitter using the Virtual IoT hashtag. Make sure to send your questions like as you have questions whenever you have them, so as we can answer them before the webinar actually ends, right? So, Marcus, up to you.
Thank you very much, Benjamin. Hello, everybody. Thank you very much, Benjamin, for the introduction. So my name is Marcus Munzet. I am from Generative Software, which is a small company in the southwest of Germany, where it's pretty cold right now. And we are focused on, as the name says, on model-driven software development and on Java. And in 2015, we joined the Eclipse working group for IoT. And let me see. And then we mainly joined. The reason why we joined was because we wanted to focus our modeling and code generation capabilities on the field of IoT and the Eclipse community. We think this is a really good breeding ground for such efforts. So in the meanwhile, during the last 2 years, we came up with a demonstrator how you can use Eclipse technologies, Eclipse IoT projects to develop an IoT solution. And these two slides and in this overview of the 3 pillars of IoT solutions is from the great Eclipse IoT white paper, which came out in autumn last year. And we, with our technology, are located right here. We provide tools and modeling languages and techniques to support the development of such IoT solutions. And what I'm showing right now is how we came up with our demonstrator, which is a greenhouse, a mini greenhouse, which is smart. We had a look at, as many people do, at the Eclipse tutorial, which was a great place to get in touch with the MQTT and co-op protocols and some of the most important Eclipse IoT projects. And then we thought, well, we want to go one step further. So we wanted to make it a bigger example with a bigger software architecture underneath it. So we were thinking about some use cases for a smart greenhouse, which you can see right now here. And I will show you these use cases later during this presentation. And we also wanted to collect data from the greenhouse in a database. So what did we do? We thought about, well, we need hardware, at least, not only computers, but also not only electronicals. So we bought from IKEA a mini greenhouse for around €20, which had the ideal size for our greenhouse, for our smart greenhouse. We assembled it. We added some ingredients like a Raspberry Pi and some sensors and some software, as I said, and then we connected it to a network. And finally, this is the result of our efforts. Here you can see it's a picture of the greenhouse. Here you can see the Eclipse, sorry, not the Eclipse, the Raspberry Pi, which is not from Eclipse, one of the few things which is not from Eclipse. And here you can see sensors and an LCD display, which shows all the measured values. And here on the left side, you see a notebook where we run the Mosquito, which is also from Eclipse, the Mosquito MQTT broker, and we run an application, an Java Enterprise Edition application, wherein we use Paho to collect the data that we create by reading sensor values over here. So on the left side, you can see these are the Eclipse projects that we are using in our demonstrator. And on the server side, we use some Java technologies that are listed over here on the right side, which is not the main focus in today, because we are looking more at on the gateway side, which is over here. So let's step further so you can see more things that are in action. By the way, if you have questions regarding any of the projects or the approach that we are taking, feel free to ask them on Twitter and on YouTube. And this is why we are doing a live meetup, so we can interact with each other. I can try to answer them immediately then. Apart from the use cases, we are thinking about what should the software itself really do. So on the gateway, we read sensor data, and then the idea was also, or the plan was also to execute some business logic on the which are the use cases that I was showing right before, and then send the data to the Mosquito message broker. Now let's show the greenhouse in action. You will see videos right now, but I also have the greenhouse over here. But it's easier to show it on a video thing, but for the live stream, so I can show you some things in it. Just a second, let me show it this way. So this is the greenhouse. We have this is the power supply for the greenhouse. Here we have a 5-volt power supply for the Raspberry Pi and some sensors. And here we have a 12 volts power supply that we need because we have a water pump that needs more power over here. And here's the router, which has the purpose of connecting all things together. All things means that the notebook and or other computers and the greenhouse itself. That was too quick, but just a second. So. You can see the display is rotating and showing all the numbers one by one, the temperature and the let's wait a bit, the air pressure and things like this. And what's going on right now? So here you can see the sensors that are facing towards the plant. It's a gas sensor the MQ2 is a standard for gas sensing. We didn't use what's the English word for it? Carbon dioxide sensor, because they're really expensive. And for us, for a demonstrator, we were searching for a cheaper sensor. We have a barometer, temperature, luminosity, and we are measuring motion over here. And here you can see a camera, Raspberry Pi camera, which takes a picture in a regularly takes a picture in order to be able to later come up with a time lapse. What's it called? Time lapse? Zeitraffer. Time lapse.
Yep.
Whenever the color is going on the camera, it's taking a picture over here. So here you can see it from the top. There's an LED stripe around here, and there is here you don't see a plant, but you see a glass of water. This is a soil moisture sensor. If the soil gets too dry, the application on the Raspberry notices this and switches on the pump, the water pump, to let the water pour over the plant, over the soil. And here we have this is not board, but we made it ourselves. It's a board to connect all the sensors together. Because by using some bridges to connect lots of sensors to the Raspberry Pi, we experienced some instabilities, and that's why we came up with our own board to have a more stable connection and to a more stable access to all these sensors. And here you can see a analog to digital converter, because we have also, you can see it right here. That's that small little thing, because we have lots of analog sensors as well, and in order to be able to read the values, we need a converter before the data gets to the Raspberry Pi. Here you can see a relay. This switches the pump, which is here, on and off. And over here is a buzzer. The buzzer has the purpose of making noise in case the gas sensor detects gas being available, being present. So you have a closer look at the LCD display. You can see here it's from Adafruit. It's really helpful. So you can see what's going on right on the inside the Raspberry Pi and with the reading of the sensors, without having to attach a big monitor to the whole thing. So here are the use cases. The water is pumping, as you can see here. Now it's stopping again. And we simulated the use cases like when it gets darker and the luminosity sensor is hidden, the light over here gets brighter. And if the temperature gets up, the color of the light is getting a more a colder color, like it's getting more bluish, as you can see right now. And you might notice it's not reacting immediately. The reason for this is the sensors do not cause an interrupt when something changes and immediately inform the Raspberry Pi about this. It's rather the opposite. It's a pulling mechanism. So the Raspberry Pi, the software that is running on it, reads the sensor data in a regular interval, and we read it every 5 seconds. That's why sometimes it takes a bit of time to react. This is the gas sensor. You can't hear sound. When we recorded this, the sensor, the buzzer didn't work. I don't know why. So these were and this is the real. I have to switch to the camera now. Just a second.
So maybe a quick reminder to everyone who's watching the webinar. If you have any questions for Marcus, I guess, I mean, that's a very complete setup, right? So maybe you have questions regarding the hardware setup, and we'll get soon into the software too. So you may want to have questions about that as well on YouTube or on Twitter using the Virtual IoT hashtag.
And so over here you can see the real greenhouse, and here you see the notebook that is connected, and see here you can see the data coming in that is currently measured. I'm not sure whether you can see it close enough. We use the JSON format to serialize the data of measured sensor data and send it over the wire. And so you can see it here in a human readable form. There's lots of things going on here on the in this screen here, because we send all the data over here, and all the sensor data is shown here. So let's go back. So this was the part about the hardware and the greenhouse, how it works. So now let's go back to the presentation and have a closer look how we have developed the software. I mean, when you have an IoT solution, you have some components like the gateway, which is in our case Raspberry Pi with Kura running on it. You have device access. You have on the cloud, also on the server side, you have data storage. You have to be able to have other applications like those ones to read the data and process it. And you have enterprise integration. In this presentation, and in this case, I'm focusing on this part, the gateway software. And what we really do to develop this software, we modeled it with a textual modeling language to model the sensors and the way we use them and the application. And we then use a set of some code generators that run on the Virtual Developer platform to automatically generate a big portion of the code that is required for this IoT solution. In the beginning, we had our, we still have it, our own textual modeling language, which is not Eclipse Vorto. And then Eclipse Vorto came up and came into being. So from then on, we use our own code generators with a different input, which comes from the Eclipse Vorto repository. Let's tell you something about Eclipse Vorto, because maybe not everybody knows about Eclipse Vorto. It's one of the Eclipse IoT projects which has the purpose for providing modeling languages and a model repository to describe or to create so-called information models. Information models include a description of devices, sensors, actuators. It starts from small sensors and goes up, and you could even create a model of a whole car if you want. So, and then there are on the right side, you can see platform vendors who provide code generators that take those models and generate code to ease the integration of those devices into their own IoT platform. And last but not least, there are solution developers that use the models as well as the code generators to finally come up with real IoT solutions. And what I'm showing you right now and afterwards, in what we did, we actually played all three roles in our case with the greenhouse, because we created the greenhouse and we created the model. We created code generators for the Eclipse IoT platform. And then we used all this to develop an IoT solution. There are several ways to execute, to call those code generators. This here is a screenshot, and I'll show it live right after, where you can select so-called information models, and you are presented with a set of code generators that you can use to create code for the model of the devices. Like here, in this case, the device is the greenhouse. To get again an overview and to understand where Eclipse Vorto is positioned, Eclipse Vorto is there to model devices. You can't model gateways or anything which is on the server side or applications like here, which is fair enough, because that's what Eclipse Vorto is focused on. That's their purpose, their idea behind all this. And we, with Vorto Developer, we go a step further. Our goal is to be able to model whole IoT solution, which includes server stuff and applications that are used and that process data and consume data which was collected before. So now let's step over and show you how we do this by using Eclipse. So this is my Eclipse, but it's a bit too fast because I wanted to start with the repository. Let me do it this way. Okay, so here you can see Eclipse Vorto, and from here you can go to the model repository. And in the model repository, you can search. There you find all the models that are available. So if you click on information model and search there, you see all the available information models over here. There are things like Texas Instruments Sensor Tech and the XDK from Bosch and some other things. And there is also the greenhouse over here, our smart greenhouse, which we modeled, which we provided in this repository as well. So let's have a click here. Here you can see, as I mentioned before, all the code generators that are available on the Vorto repository. And you see a model preview, which shows the textual representation of the model. Here you can see, for instance, things like MQT gas sensor and the light strip, the LED strip. And if you click on such a generator, the generator on a server creates the model, sorry, not the model, the result. And as a result of this, you get a zipped archive with all the code inside. For some platforms, it's what you get is configuration files, XML stuff, for instance, and for other code generators, you get source code. When you use the IoT gateway for Kura code generator, then did I click it? Oh, yeah. Then you get not the configuration, but you get source code back in a zip file. So this is one way how you can access the code, use the models from Vorto and the code generators. Now let's head to the Eclipse, which I have here. I have no idea how you can increase the font of those things here. That's but I know that you can, if you look at the editors, you can easily increase the size. So of the text. I'm switching now to the, this is Eclipse Neon, which I'm using here. And on the left side, you see some models. Like what you see here is local. So if you click on the greenhouse over here, you can see our greenhouse model, which is stored locally. We got it from the model repository of Vorto. You get it by, you have a special view, the model repository view, that you can search for, like this, greenhouse. And then you see the content or the models that are available on the Vorto repository, and you can drag and drop them to your local Eclipse to continue working with them, to change them, or to use parts of it in new models. So let's open something else. So I have a comparison. Let's quickly show the this is now also a textual model, which is our own textual modeling language, which is similar to Vorto. But we don't have a repository for that. So in our case, our textual files, model files are locally. But the modeling tool to use to do this is also based on Eclipse, the Eclipse modeling framework. So now let's show you a different way how you can use Vorto models to generate code. This is a view of the virtual developer code generation platform. And here you can see so-called generation projects. There is one here for the IoT gateway for Kura with Vorto models. This is the same. This generator here, GApp Vorto Kura, is exactly the same code generator that is can be used from here. That is available over here to be called through the Vorto repository platform. But when you call it from here, you have the benefit of not having to use a zip file and copy thing over because the code is directly written then to the Eclipse projects, which are found in this workspace over here. As oops, let me see. The inputs that I use for the code generators over here is nothing else like that I can find it quickly. The input for this code generator from here is just the information about the model in the repository. So this is the name, and you have the namespace and the version, which you can also see over here. The name, the namespace, and the version. So in this case, when you run the code generator here, code generation, this information is sent to a server, and from there the Vorto repository is being accessed to get the model. Only accessible through the web page like this. you have it provides a REST API that lets you access models from everywhere. So we, in this case, over here, we get the model from a REST API call to the repository. So I'm not sure whether I just have run it. Let's do it again. Here you see what's going on in status bar. Here you can see the number of files into the Eclipse projects. Alternatively, there's a third way how you can do the code generation. You can, as you can see here, the Vorto models are also here locally. They have file endings like FB model for function blocks, info model for info models, and you can simply provide these as input for a code generator like this. So in this case, the model goes from the workspace, and all the models are sent to a remote code generator. And there is a third way how you can do this. A fourth even. Just to highlight what you can do to access all this. If you go to the virtual developer portal and takes a bit of time. Well, it's now it's written in German, so but I can tell you what it is. So you select a code generation project, the IoT gateway for Kura with Vorto models. And you can even use the code generation through the web interface of Virtual Developer. Here I have prepared a zip file, a predefined model which includes all the model files of the greenhouse, of the Vorto model of the greenhouse. And if you generate it, you can, once it's ready, you can have a look at the results over here, like, let's have a look at device drivers. And here you can have a look at the results of the code generator. You can't code here, it's not an IDE, but it's just for being able to quickly see what's going on and what is the result of a code generator. And you could even select your own models from the file system and send it to a code generator over here. So, but we did not have a look at the results of the code generation itself. So what you can see over here, although it's pretty tiny, the font, you have some Eclipse projects. Those ones are for the gateway software, which runs on the Raspberry Pi of the greenhouse, and every Eclipse project over here represents an OSGi bundle, which has a certain purpose for the software on the gateway. Like, for instance, device data. Here you find data structures for the different sensors, like light strip data. These classes are being used by the software to hold the sensor data and to work with it. Then you have device driver, which has some generated source code that has the purpose of accessing the sensors. Like, let's have a look at a temperature sensor device driver. Here you can see this code is manually written over here. This is the way, this is code for accessing the sensor through by means of Java code and get the data from there. Then you have other things like device service, which has the purpose of providing, let me see, it's even small for me. It has the purpose of providing one interface and one implementation. Maybe it's easier to see if I look at the interface that gets generated. That it's a predefined interface and an implementation for accessing sensor data without having to fiddle around with device driver classes and low-level stuff. So any business logic that we have implemented over here means running on the gateway, uses this interface over here to get the data from the sensors and to set data for the actuators, to control the actuators. While mentioning the business logic, let's show some business logic. Like for the temperature sensor. So if you have a look at the business logic over here, whenever the temperature changes, for a certain amount of Celsius, the degrees Celsius, this method gets called, and this is all generated, and you only have to, you can code your business logic over here. And with this get device service, you get the interface values from sensors. You even can get history value from sensors if your logic depends on this. And you can also set data for, like for instance, here we set the light use case. When the temperature gets lower, the color of the LED gets more reddish, and if it gets warmer, the color is more bluish. All the software which is over here, that's not a private thing. It's available on a Bitbucket repository, on a public one. And all this, we provide all this code here in under the Eclipse public license. Let me show you where you can find it. So it's over here. So if you are ever interested in to see to play around with this code and to see how it's being done, how the access is coded, how the co-op is being used. I didn't mention co-op so far. There's a Californium Eclipse project which provides a co-op server over here, which runs also on the Raspberry Pi in order to be able to access the smart greenhouse directly by means of co-op. So here in the subdirectory gateway, you find all the Eclipse projects that are required to run on the Raspberry Pi. There is one exception. This is the device simulation service. The code generator also creates a bundle which is not supposed to be run on a real gateway, but is supposed to be executed locally in your Eclipse and has the capability of simulating data, sensor data, being sent to an MQTT broker. And this simulation service, you can run it like in Eclipse you can find run configuration category that is capable of running OSGi applications, and you can use this one to execute a simulated gateway software without having any hardware. It's taking a bit of time to open up the run configuration dialog here. I'm pretty sure it will do it.
So maybe in the meantime, a quick question for you. Besides
Yes.
generating actual code, do you see opportunities for generating more than code? I know, like maybe around security. Is there anything that modeling could help do by means of modeling the access control rules on devices? Because it looks like what you've demonstrated is very much focused on the capabilities of the devices, but I bet there's more that you can do with models, right?
Yes, there is much more. We, as I mentioned during the presentation, we are not limited to the gateway stuff. Our goal is to get much further, and also to be able to provide modeling and generation support for security aspects. The thing is here, to be able to come up with modeling and code generation solutions for this, you need experts in all these domains like security and other stuff, like server-side stuff. And we don't know everything. We don't know. We're not experts in every aspect. But by working together with partners, we can together in joint efforts provide also code generators and modeling capabilities to cover these areas, these domains as well, like security, as you said.
Yeah, that makes sense.
And so here you can see OSGi framework category, and here we have prepared, in this case here, a launch configuration for the smart greenhouse gateway software, but this is just a simulation. This is not the software that's running on, that's not the Kura stuff. And the last thing about the code, because I don't want to speak too much about code at this point, but which might be important, we do not generate test data. Instead of generating test data, we generate an application that is capable of creating test data, because in different situations you need different test data, and we as a code generator don't know enough about how should test data being generated to fit to a certain use case. That's why we just generate code that is capable of running, that can be extended with the logic to create test data. And since we can reuse the data structures over here, the data structures that are being used for holding sensor data, we can be sure that the format of the data for the simulation is exactly what is required for the server side to be processed. It's a big benefit over here. Let me show you what I already have generated. Like for temperature simulation, I have already created. Let me show the it's over here. No, it's the wrong one. The last one, always the last one. So this is a generated code, temperature accessor. And here you can write, let me show you the code that creates the, no, that's the wrong one. Again, the wrong one. That's the temperature tester. So, sorry. That's the one. So here you have, there's manually written code. It's pretty simple that creates temperature data. Over here, let's stop here. This, now finally I have it. This is the code that creates test data for temperature data, which is a set of temperature data which always increase by 0.1 degrees Celsius. And that's why I'm getting the test data which looks like this: 20, 20.1, 20.2, and stuff like this. So that's, I think that's everything I can show you and explain you within 45 minutes. So I'm now open for questions.
Thanks very much, Marcus. So yeah, quick reminder: if you guys have questions for Marcus, that's something you should ask on either your YouTube channel or using the virtual IoT hashtag on Twitter. So can you maybe say a few words about the roadmap for Eclipse Vorto? Like, do you think what's needed is more around like more generators or more models? What's next basically for modeling and IoT?
In my opinion, it's a few questions. The roadmap of Vorto, well, I'm not from the Vorto team, so I don't know what they have in the plans, but from what we are in close contact to them nonetheless. And as far as I know, they are focused on the device side, and which is complicated enough to have all the things settled. And what I think is because an IoT solution is not just devices, it's more than that. There are many portions of IoT solutions, and I think to have a real an even bigger benefit of using models and code generators, we need to have models that integrate with each other. It doesn't help a lot if you have 5 different modeling solutions and 5 different code generators, but what they create doesn't fit together, and the models don't fit together, and they are maybe different tools. So I think we should have more closely integrated models and code generators. It's actually a bit of the same as for IoT solutions, where all the hardware has to be integrated. Different.
Yeah, that's right. And maybe on the point of integration, do you plan on extending your demo / tutorial to cover more server stuff, like maybe have code generation for Eclipse Kura? Maybe would that be in your kind of ideal roadmap?
Yes, in our ideal roadmap, this is definitely part of it, because we want to be, as I mentioned in the beginning of the presentation, Eclipse IoT is we see it as the best opportunity to show how because all is open source and there is lots of stuff going around it, to show how you can develop IoT solutions. And for us, it's a logical consequence, a logical step to say, okay, we extend the code generation logic available to be able to use all the Eclipse projects, Eclipse IoT projects, to come up with real solutions. And Kura definitely is part of it. Okay,
cool. I think, well, we're slowly getting to the end of the hour. So this is a recorded webinar. So everyone, if you're interested in checking out what Marcus has been working on. He put the links at the end of the slide deck. We'll also upload and make the slides available and make sure that the links are available in the description of the YouTube video. I'm actually very excited to see this little tutorial that I've probably started to work on more than 2 years ago, maybe, that's been kept up to date by the community, by people like you, Marcus. That's really why open source is so important for IoT, in my opinion. Right, the community extends the core use cases and the core stuff that's available out there. So that's really cool. If you guys have questions for Marcus after the fact, after the webinar, just comment on YouTube, and we'll make sure to forward the questions to Marcus. We will be back next Tuesday. We actually have more and more webinars lining up. So next Tuesday is going to be about Eclipse Smart Home and a slightly different approach to smart home and to programming by means of integrating smart home and Minecraft. So that's going to be something I'm very much looking forward to. Other kind of general announcements, please make sure to let us know what you guys would like to see. If you're interested in speaking at the meetup, just shoot us an email at iot@eclipse.org. You can also, and you should, review the group on meetup.com. Send us your comments, evaluate the quality of the webinars. You can also directly comment on each webinars and give your feedback, your rating. We are very interested, actually. And I think, well, maybe before we leave, do we have one last question? Well, maybe that's something we'll take offline, or I will point. So Rafi is asking, what are the techniques available at Eclipse IoT? What are the projects available for doing remote patching or flashing of IoT devices? We've done webinars in the past about lightweight M2M, which is a very relevant open standard for doing remote over-the-air upgrades. So if you look at projects like Eclipse Wakayama or Eclipse Leshan, that should get you started. So either you look like Google and you look at the project pages, or in the archives of the meetup on YouTube, on the YouTube channel, there's a presentation on lightweight M2M and Leshan. So you may want to look at that. If you have further questions, feel free to reach out. So I think that's a wrap. Marcus, thanks very much. That was really like a very complete, very exciting demo of Eclipse Vorto and more, actually. So thanks for that. And to everyone watching the webinar, see you next Tuesday. Bye-bye.
Thank you very much.
Thank you, Marcus.